In this video, we're going to talk about electric charge. The first you want to know is the types of electric charge you have. We have two types of electric charge. One is called a negative charge, represented by a minus sign. A positive charge, represented by a plus sign. So these are the two types of charge we have, a negative charge and a positive charge. So the next you want to know is the particles that carry this charge. That is, where can you find this charge? So that will take us to subatomic particles. So we're going to talk about the particles, the type of charge they carry. Is it a negative charge or a positive charge? Then how much charge do they carry in coulomb? Note that the C here means coulomb. Then the mass of the particles in kilogram. This means how heavy the particles are. Now we have three subatomic particles: the electron, the proton, and the neutron. So what type of charge does the electron carry? Electron carry negative charge, and the proton carries positive charge. How about the neutron? The neutron is neutral. Now, how much of this negative charge is in electron? One electron has about negative 1.602 times 10 raised to the power of minus 19 coulomb. Then the positive charge has about positive 1.602 times 10 raised to the power of minus 19 coulomb. So both carry the same magnitude of charge, only that the electron carry negative sign, while the proton carry positive sign. So how about the neutron? How much charge does it have? The neutron has zero charge. It has no charge. Now let's talk about their mass. The electron has about 9.109 times 10 raised to the power of minus 31 kilogram. The proton has about 1.673 times 10 raised to the power of minus 27 kilogram. And for the neutron, it has about 1.675 times 10 raised to the power of minus 27. Before we solve related problems, you need to be familiar with all these values. If you have a jotter, you can jot them down. So as we've discussed, one electron is equal to negative 1.602 times 10 raised to the power of minus 19 coulomb. And one proton is equal to positive 1.602 times 10 raised to the power of minus 19 coulomb. So let's keep this for later. Also, mass of one electron is equal to 9.109 times 10 raised to the power of minus 31 kilogram. Note this M means mass and the E means electron. And the mass of one proton is equal to 1.673 times 10 raised to the power of minus 27 kilogram. Also, the mass of one neutron is equal to 1.675 times 10 raised to the power of minus 27 kilogram. So let's keep this also for later. So now let's try to solve some related questions. So the first question here is, if 3 electrons were transferred to a neutral metal rod, what would be the electric charge of the metal? So the question is, if a metal has 3 electrons in it, what will be the charge of the metal? So this represents charge, which is what we are going to calculate for. Now to solve the question, we are going to use this as our conversion factor. So we're going to do it this way. If one electron is equal to negative 1.602 times 10 raised to the power of minus 19 coulomb, then 3 electron will be equal to what? So remember, we are looking for Q, that is the charge. So we're going to write Q. Now cross multiply, that is 1E multiplied by Q and 3E multiplied by minus 1.602 times 10 raised to the power of minus 19 coulomb. So 1E multiplied by Q will be EQ. 3e multiplied by minus 1.602 times 10 raised to the power of minus 19 coulomb. First multiply 3 by minus 1.602, then you will have minus 4.806 times 10 raised to the power of minus 19 C E, that is multiplied by this E. Now to get your Q, divide both sides by E, that is here divide by E, and this divide by E. E cancel E, remaining Q equal to E cancel E, remaining minus 4.806 times 10 raised to the power of minus 19 coulomb. So this is our answer. And this is how we can find a charge in a case like this. So question 2, what is the total electric charge of 40 kg of protons? That is, how much charge we give 40 kg of protons. So one proton has this value of charge and also has this magnitude of mass. So basically this value is equal to this value. So in this case, our conversion factor is going to be these two values. That is, if plus 1.602 times 10 raised to the power of minus 19 coulomb is equal to 1.673 times 10 raised to the power of minus 27 kilogram, then how much charge will be equal to 40 kilogram? Now cross multiply. So Q multiplied by this will be 1.673 times 10 raised to the power of minus 27 kilogram times Q. Multiply these two as well. Then you're gonna have positive 1.602 times 10 raised to the power of minus 19 times 40 kg. Now to get your Q, divide both sides by the coefficient. That is, this side divide by 1.673 times 10 raised to the power of minus 27, and this side divide by 1.673 times 10 raised to the power of minus 27. Now this cancel this, remaining Q. Divide this, you will have 0.958 times, according to your indices, bring this power up here. So you're gonna have 10 raised to the power of minus 19 plus 27. Your sign is gonna change from minus 27 to plus 27 times, we forgot to include the units coulomb. Now this kilogram cancel this kilogram, will be left with 40. So 0.958 times 40, that will give you 38.32 times 10. Minus 19 plus 27 will give you 8 in coulomb. This is your answer, but it is preferred to be more standard. And according to your standard form, move the point here, which will increase the power by 1. Remember, in your standard form, when you move a point to the left once, it will increase the power by 1. If you move it twice, it will increase it by 2. If you move it 3 times, it will increase the power by 3, and so on. So our final answer is gonna be 3.832 times 10 raised to the power of 9 coulomb. So remember to include the positive sign to show you are talking about proton. So this is the charge of 40 kilogram of protons. That is pretty much. So this is how you can calculate an electric charge in this case. Try these practice problems and drop your answers in the comments. And if this video is helpful, like and subscribe.